Hello students, welcome back to my new lecture on physics for class 11. Today we will solve numerical problems of chapter number 2, that is units and measurement. Numerical problems are very important from the point of view of your examination as well as understanding the concepts of units and measurements. Please open your book and pen and note down all the important points discussed in this. Wherever I am going fast, you can pause the video and review the video lecture. Welcome you once again. Numerical problems. Question number 1. Determine the number of light years in 1 meter. We have to recall or remember that 1 light year is equal to 9.46 into 10 to the power of 15 meters. This relationship you have to remember it, and that is why it is given in red. So if 1 light year is equal to 9.46 into 10 to the power of 15 meters, then 1 meter will be equal to 1 over 9.46 into 10 to the power of 15. Simplifying, we get 1 meter equals 1.057 into 10 to the power of minus 16 light years. That answers the question. Next question. Question number 2. The sides of a rectangle are 10.5 plus or minus 0.2 centimeter and 5.2 plus or minus 0.1 centimeter. We calculate its perimeter with error limits. Please note the sides of a rectangle are 10.5 and 5.2 centimeters. The error is plus or minus 0.2 in one side, in the other side it is plus or minus 0.1 centimeter. So we are required to calculate its perimeter with error. So we know perimeter is equal to twice of length plus breadth, that is L plus B, that is equal to plus or minus. The error is also 2 into delta L plus delta B. Here L is 10.5 and breadth is 5.2. And error is delta L is equal to 0.2 in the first case and plus delta B in the breadth is 0.1 centimeter. Therefore, substituting and putting the values, we get 2 into 10.5 plus 5.2 plus or minus 2 into 0.2, that is delta L plus delta P is 0.2 plus 0.1. Simplifying, we get 31.4 plus or minus 0.6 centimeter. That is the answer. Next question. Question number 3. The mass of a box measured by Grosser's balance is 2.3 kg. Two gold pieces of 20.15 grams and 20.17 grams are added to the box. Question number 1, part 1 is what is the total mass of the box? Question number 2 is the difference in masses of the pieces to the correct significant figures. So it is given, please note the mass of the box is 2.3 kg. It is given in kg. Whereas the gold pieces weight is in grams, 20.15 gram and 20.17 grams. So we will solve the question. Answer. First we will take mass of the box given, it is 2.3 kg. Therefore, mass of gold pieces is also given 20.15 gram plus 20.17 gram, that is equal to adding 40.32 grams. Therefore, that is in terms of kg, converting into kg, we have to divide it by 1000. That becomes 0.0402032 kgs. I read once again, 0.04032 kg. Therefore, total box plus gold is 2.3 plus 0.04032 kg. Therefore, it is adding 2.34032 kg. Therefore, incorrect significant figures of mass, if you correct it to this significant figures, it is 2.3 kg as a least decimal. Therefore, that is the answer. And part 2 is difference in mass of gold pieces is 0.02 grams. That is the difference of 20.17 minus 20.15. That is equal to 0.02 grams. Therefore, incorrect significant figure, two significant figure, minimum decimal will be 0.02 gram. That is the question number 4. 5.74 grams of a substance occupies 1.2 centimeter cube. Express its density to correct significant figures. Answer. We know density is equal to mass over volume. So mass is given as 5.74 grams and volume is given as 1.2 centimeter cube. Therefore, substituting for mass and volume, we get 5.74 divided by 1.2 is equal to 4.783 grams per centimeter cube. Therefore, here the least significant figure is 2. That is the volume. So, density is equal to 4.8 grams per centimeter cube. Question number 5. If displacement of a body S is equal to 200 plus or minus 5 meters and time taken by it is t is equal to 20 plus or minus 0.2 seconds, then find the percentage error in calculation of the velocity. Answer. Percentage error in measurement of displacement. Displacement is 200 plus or minus 5. Therefore, percentage error is given by, in displacement is given by delta S over S. That is, delta S is 5 for displacement divided by 200. That is equal to 2.5%. 5 by 200 into 100 is equal to 2.5%. Percentage error in measurement of time is given by delta t. Delta t is 0.2 seconds divided by 20 seconds into 100. That is equal to 1%. Simplifying, we get 1%. Therefore, maximum permissible error is 2.5 plus 1. That is equal to 3.5%. Next question. Question number 6. If the error in measurement of mass of a body be 3% and in the measurement of velocity be 2%, what will be the maximum possible error in calculation of kinetic energy? Here, the errors of a mass as well as velocity is given. We have to find the maximum possible error in calculation of kinetic energy. For that, we should know the formula for kinetic energy. Let us answer it. Answer. We know that kinetic energy is given by the relations. Kinetic energy is equal to half into mv square, where m is the mass and v is the velocity. Therefore, For calculation of error, we have to differentiate. That is, delta k by k is equal to delta m by m plus delta v by v. Therefore, delta k by k is the error in kinetic energy is equal to delta m by m, that is error in mass, plus 2 times. This 2 is due to v square. The error here gets doubled. Therefore, 2 into delta v by v. And for calculation of percentage, we have to multiply each term by 100. Therefore, delta k by k into 100 is equal to delta m by m into 100 plus 2 into delta v by v into 100. Therefore, percentage error in kinetic energy is equal to, it is given delta m by m as 3% plus 2 into delta v by v is given as 2%. 2 into 2%, that is equal to total 3 plus 2 into 2, that is 7% is the error in the kinetic energy. Question number 7. The length of a rod as measured in an experiment was found to be 2.48 meters, 2.46 meters, 2.49 meters, 2.5 meters and 2.48 meters. Find the average length, absolute error and percentage error. Express the result with error limit. So we have to calculate three things. We have to find the average length, then we have to find the absolute error, and we have to find percentage error. And we have to express the result in error limit. So let us answer it. So average length is given by sum of all the 5 measurements divided by number of measurements. Therefore, adding we get 2.48 plus 2.46 plus 2.49 plus 2.5 plus 2.48 divided by 5, because we have taken 5 measurements. That is equal to 12.41 divided by 5. That is equal to 2.48 meters. Therefore, mean absolute error is, we have to find the error in each reading. We know the average length is 2.48. So each we have to find a difference between the measured value and the average value. Therefore, the first reading is 2.48. 2.48 minus 2.48 is 0.00. The next reading is 2.46. The difference between 2.46 and 2.48 is 0.02. Plus the third reading is 2.49. The difference between 2.49 and 2.48 is 0.01. Plus the fourth reading is 2.50 meters. And average value is 2.48 and difference is 2.50 minus 2.48, that is equal to 0.02. Plus the last reading, that is fifth reading, is 2.48 and average is 2.48. So error is 0. It is written as 0.00. That is divided by all the 5 readings, that is 5 measurements divided by 5. So we get, adding and dividing, we get 0.01 meters. So mean absolute error is 0.01 meters. That answers the second part. Now we have to find the percentage error. So therefore, percentage error is given by 0.01 meters divided by the average value 2.48 into 100. That comes to the answer 0.04 into 100. So percentage error is 40%, 0.40%. So 0.4% is the percentage error. So the correct length is 2.48 plus or minus 0.01 meters. That is the absolute error. Average value plus or minus 0.01 meters. And the correct length is 2.48 plus or minus percentage, in terms of percentage, 0.40. So therefore correct length is 2.48 meters plus or minus 0.40. Please note the difference. In the correct length, in this line we have written as meters. the error is also in meters, whereas here error is in error limit, that is 0.4%. Next question, question number 8. A physical quantity is measured as Q is equal to 2.1 plus or minus 0.5 units. Calculate the percentage error in 1 Q square. That is, Q is given, we have to find the error in Q square. And the next part, second part is 2Q. That is, Q is equal to, in the second case is 2Q. Let us find it. 1. Let P is equal to Q square. That is part 1. Therefore, error is given by delta P by P is equal to, because square is there, 2 into delta Q by Q. Therefore, that is equal to 2 into 0.5 error it is given, delta Q is 0.5, it is given here, divided by 2.1, that is value of Q is equal to 2.1, that is equal to, simplifying, we get 1 divided by 2.1, that is equal to error in physical quantity P equals Q square is 0.46. Therefore, delta P by P into 100 is equal to 0.46 into 100. That is calculating in terms of percentage. Therefore, error is 47.65, that is equal to 48%. Correcting it to the significant digit is 48%. Second part, R is equal to 2Q. In the second part, it is asked, question asked is for 2Q. Therefore, let R is equal to 2Q. Therefore, delta R by R into 100, that is error in R is given, percentage error is delta R by R into 100 equals, this is constant, so no measurement, only Q, delta Q by Q into 100. That is equal to, delta Q by Q is 0.5 divided by 2.1, and that is equal to 0.238. Please note, in terms when P is equal to Q square, you have to take twice delta Q by Q. Whereas in this second case, 2Q is given, so 2 has to be ignored and we have to take delta Q by Q only. Because Q is to the power of 1 only. So therefore, percentage error in R is 0.238. That is equal to, in terms of percentage, we get 0.238 into 100. That is equal to 23.8%. That is approximately, correcting it to the significant figures is 24%. That answers the question. Next question. When the planet Jupiter is at a distance of 824.7 million kilometers from the Earth, its angular diameter is measured to be 35.72 seconds of arc. Calculate the diameter of Jupiter. Answer. So it is given theta, the angular diameter, angle is given as 35.72 seconds of an arc angle. It is given. 1 second, we have to remember 1 second. We have to remember that 1 second is equal to 4.85 into 10 to the power of minus 6 radians. That is, angle is expressed in the terms of radians. We get that become 35.72 seconds will be equal to 35.72 into 4.85 into 10 to the power of minus 6 radian. And we also know the distance d is equal to capital D theta. That is, the diameter, angular diameter d is equal to d, capital D is the distance of the Jupiter from Earth, capital D, and theta is the angular diameter. So it is given D is equal to the diameter of Jupiter is equal to D. Capital D is given as 824.7 million kilometers. Therefore, that is 824.7 into theta is 35.72 into 4.85 into 10 to the power of minus 6 radians. That is the right hand side of the previous equation, this equation. Simplifying, we get 1.4287 into 10 to the power of 5 kilometers. That is multiplying by converting million kilometers into kilometers, we get 1.4287 into 10 to the power of 5 kilometers. Question number 10. A laser light beam at the moon takes 2.56 seconds and to return after reflection at the moon surface. So, time taken to travel to moon and return after reflection is 2.56 seconds. What will be the radius of lunar orbit? So, we have to calculate the radius of the lunar orbit. So, it is given t is equal to 2.56 seconds. Therefore, t is the time taken by laser beam to go to moon is t by 2. That is, go and return is 2.56 and only go is t by 2, half of that. That is equal to the distance between Earth and moon is small d. Therefore, we have to calculate the distance in terms of velocity, that is c into t by 2. That is meters per second it was. That is c is 3 into 10 to the power of 8 into 2.56 by 2. That is equal to 3.84 into 10 to the power of 8 meters. So distance is given by velocity of light into time taken. Therefore, 3 into 10 to the power of 8 into 2.56 by 2, that is equal to 3.84 into 10 to the power of 8 meters. That is the answer. Question number 11. Convert 3 meters per second square to kilometers per hour square. Part 2 is given G is equal to 6.67 into 10 to the power of minus 11 newtons meter square per kg square to centimeter cube per gram per second square. So there are two parts in this question. Let us take part 1. So given 3 meters per second square can be written as 3, that is equal to 3 into convert meter into kilometer by dividing it by 1000. So 3 into open the bracket 1 over 1000 kilometer, close it, close the bracket. Now convert seconds into hours. So that is equal to 1 over 60 into 60 hours. That is, see, first 60 is for converting seconds into minutes and then minutes into hours. So that becomes hours to the power of minus 2. So that is equal to 3.880 into 10 to the power of 4 kilometers per hour square. Next, writing the significant digit. 3, that is equal to 3.9 into 10 to the power of 4 kilometers per hour square. That answers the first part. Let us take the second part. Given G is equal to 6.67 into 10 to the power of minus 11 newtons meter square per kg square. So it is given G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So we have to convert newtons into kg meters per second square. That is 1 Newton by definition is kg meters per second square. Therefore, that is equal to right hand side is 6.67 into 10 to the power of minus 11. Convert Newton into kg meters per second square, and then meters as it is meters square kg to the power of minus 2. So simplifying, we get 6.67 into 10 to the power of minus 11. So this kg plus 1 and this minus 2 to the power of minus 2 becomes kg to the power of minus 1. Meters and meter square. So that becomes meter cube, combining these two m's, and per second square as it is. Now we will convert kg into gram and meters into centimeters. So right hand side becomes 6.67 into 10 to the power of minus 11 into 1000 grams. 1 kg is 1000 grams. Therefore 1000 grams to the power of minus 1 into 1 meter is 100 centimeters. Therefore that becomes 100 centimeter whole cube second square to the power of minus 2. So then right hand side equals 6.67 into 10 to the power of minus 11 as it is. 1000 grams to the power of minus 1, it becomes 1 over 1000, and centimeter cube is 100 into 100 into 100 centimeter cube per gram per second square. That becomes right hand side is equal to 6.67 into 10 to the power of minus 11 into 10 to the power of cube 10 cube 3 10 to the power of 3 centimeter cube per gram per second square. Therefore, it can be written as 6.67 into 10 to the power of minus 8 per gram centimeter cube per second square. That is the answer. Next question. Question number 12. A calorie is a unit of heat or energy and it equals 4.2 joules, where 1 joule is equal to 1 kg meter square per second square. Suppose we employ a system of units in which a unit of mass is an alpha kg and unit of length is beta meters and unit of time is gamma seconds. What will be the magnitude of calorie in terms of this new system? That is, we have to convert old system, given system into a new system. Let us answer it. Answer. Let N2 be the new system. So therefore, N2 equals N1, that is N1 is old system, into multiplying factor into M1 divided by M2, where M1 is old system, M2 is the new system of mass to the power of A, and length is L1 in old system and L2 is new system to the power of B, and seconds is S1 in old system and S2 in new system to the power of C. And it is also given that 1 joule is equal to 1 kg meter square per second square. Therefore, and we will substitute for M2, L2 and S2. So that can be written as N1 is given as 4.2 into kg over alpha kg to the power of 1, and that is weight, and L1 is Question number 14. The frequency of vibration of a string depends on three factors. One is tension in the string, two is mass per unit length of the string, and three is vibrating length of the string. So tension, mass and length of the string. Establish dimensionally the relation for frequency. So let us answer it. Answer. Let the frequency be represented by letter n, small n, which is proportional to L to the power of A, T to the power of B, and M to the power of C, where L is the length of the string, capital T is the tension in the string, and small m is mass per unit length of the string. So we will take the dimensions separately. Vibrating length L is, it has a length only. It has zero mass and zero tension. Therefore, it is L to the power of 1. That is, L is m to the power of 0, L to the power of 1 and T to the power of 0. And tension capital T within brackets is m to the power of 1, L to the power of 1 and T to the power of -2, because force, tension is nothing but force is equal to mass into acceleration. Mass is m to the power of 1 and acceleration is L to the power of 1 into T to the power of -2. Mass per unit length is capital M within brackets is equal to mass is m to the power of 1 and unit length is, per unit length is L to the power of -1 into T to the power of 0, zero tension. Therefore, equating dimensionally, we write frequency m to the power of 0, L to the power of 0, T to the power of 1 equals m to the power of 0, L to the power of 1 and T to the power of 0. That is vibrating length to the power of A, L to the power of A. And writing dimensions of T to the power of B, we get m to the power of 1, L to the power of 1 and T to the power of -2. This is from the this is the previous steps to the power of B. And writing the dimensions of mass per unit length is m to the power of 1, L to the power of -1 into T to the power of 0 whole to the power of C. Now we have to equate the powers on the left hand side and right hand side. Therefore, B plus C, that is mass is equal to, is to the power of 0. Mass is 0 on the left hand side. Here B is B plus C equals 0. So then equating the powers of L, we get 0 is equal to, L is A here, A plus B minus C, because here it is L to the power of -1, therefore it is minus C equals 0. Therefore, and again writing the, equating the powers of T to the power of -1. So -1 is equal to -2b. Here only in the midterm -2b. So -2b is equal to -1 or b is equal to half. Therefore, C will be equal to minus half. C will be equal to -2, that is equal to minus half, and A will be equal to -1. Therefore, N, we know N is given as proportional to LA to L to the power of A, T to the power of B and M to the power of C, which can be written as N is proportional to L to the power of -1 because value of A is -1, T to the power of half because B is half here to the power of half, and M to the power of C is M to the power of -half. that can be written as that is equal to 1 over L. That is L when it can be written as 1 over L. L to the power minus 1 is 1 over L into these are all power to the power of half square root of T over M. Hence, we have proved that frequency is equal to 1 over L into square root of T over M. Question number 15. 1 mole of an ideal gas at standard temperature pressure occupies 22.4 liters. What is the ratio of molar volume to atomic volume of a mole of hydrogen? Why is the ratio so large? Take radius of hydrogen molecule to be 1 Armstrong unit. And STP, standard temperature and pressure. Answer. We know that we have to remember 1 Armstrong unit is equal to 10 to the power of minus 10 meters. Therefore, atomic volume of 1 mole of hydrogen is equal to Avogadro number into volume of hydrogen molecule. We have to remember this relationship. That is, atomic volume of 1 mole of hydrogen is equal to Avogadro number into volume of hydrogen molecule. So that is equal to, that also value we have to remember, 6.023 into 10 to the power of 23. 10 to the power of 23 is the Avogadro number into 4 by 3 pi into 10 to the power of minus 10 meter cube. So 1 Armstrong unit is 10 to the power of minus 10 meter cube, whole cube, converting into volume. Therefore, that is equal to 25.2 into 10 to the power of minus 7 meter cube. So, molar volume, it is given as 22.4 L. That is equal to 22.4 into 10 to the power of minus 3 meter cube. That is converting liters into meter cube. Therefore, molar volume divided by atomic volume is equal to 22.4 into 10 to the power of minus 3 meter cube divided by, here we have calculated the atomic volume as 25.2 into 10 to the power of minus 7 meter cube. That is equal to 0.89 into 10 to the power of 4. That is approximately equal to, this is approximately equal to 1 10 to the power of 4. That is, ratio is 10 to the power of 4. The ratio is large because actual size of gas molecule is negligible in comparison to the intermolecular separation. Question number 16. Derive an expression for the centripetal force F acting on a particle of mass m moving with velocity v in a circle of radius r. Answer. F is proportional to force. Centripetal force is proportional to mass, velocity and radius of the circle, and it is given by the relationship F is proportional to m to the power of a, v to the power of b and r to the power of c. We are required to find the values of a, b and c. So let us remove the sign of proportionality by putting F is equal to K into m to the power of a, v to the power of b and r to the power of c, where K is the constant of proportionality. So, in writing the dimensional equation, we get the dimensions of F force are mass into acceleration, that is m for mass, L into t to the power of minus 2 for acceleration. So left hand side is dimensions ml t to the power of minus 2 is equal to K is dimensionless. Therefore mass m is capital M to the power of A, and velocity v is L into t to the power of minus 1 whole to the power of b, and radius r has dimensions capital L to the power of c. Now equating the powers on the left hand side and right hand side, we get m into L into t to the power minus 2 on the left hand side is equal to m to the power of a, L to the power of b plus c, and t to the power of minus b. That is, comparing the powers of m, L and t, we get a is equal to 1. That is, m on left hand side is m to the power of 1 and a on the right hand side. Therefore, a is equal to 1. And comparing the powers of L, b plus c is equal to 1. That is, on the left hand side we have L is equal to 1, b plus c is equal to 1. Similarly, we are comparing the powers of t, we get minus 2 is equal to minus b, or b is equal to 2. From this equation, b is equal to 2, and substituting the value of b, we get c is equal to minus 1, and therefore a is equal to 1, b is equal to 2, and c is equal to minus 1. Substituting the values of a, b and c in this equation, we get f is equal to k into m to the power of 1 v square into r to the power of minus 1. That equals, rearranging, we get f is equal to k into mv square divided by r. It is divided by r because r has a power of minus 1, which goes to the numerator and becomes r to the power of 1. Next question. The error in the measurement of radius of a sphere is 2%. What would be the error in the volume of a sphere and surface area of the sphere? We should remember that volume of sphere is given by V is equal to, volume V is equal to 4 by 3 pi into r cube. So therefore, errors can be mentioned, stated as delta V. Error in volume of the sphere is delta V by V is equal to 3 into delta R by R. This 3 because of the R cube. In terms of percentage, delta V by V into percentage equals 3 into delta R by R is given as 2%. That is 2% is equal to 6%. We know surface area is given by A is equal to 4 pi R square. Therefore, writing the error percentage, we get delta A by A. That is, error in the surface area of the sphere is in percentage equals 2 times, because it is a R square factor, 2 into delta R by R percentage. 4 pi does not have any dimensions. Therefore, that can be written as 2 into 2%. That is, the error in surface area is 4%. With this, we come to the conclusion of numerical problems of our lecture. The next lecture will be exercises and question bank of chapter 2, that is units and measurement. Till then, goodbye.